Yeah, so here we have this demo control model loaded into our visualization module, and we can see directly what is our geomechanics properties along with the wellbore. So for example, this is the minimum horizontal stress. We also have the maximum horizontal stress, the Poisson's ratio, and also the Young's modulus. So you can see this is a highly heterogeneous reservoir. Now we directly support the petrol input from the into the software. And then next, this interface we can also consider the natural fractures. So for the fracturing simulation, we can consider the activation of all the natural fractures by the propagation of the hydraulic fractures. So for this demo, we don't have the natural fracture model, but if you have the FAB file from the petrol model, we can directly support that input into the software. So here we don't need to consider natural fractures. And then the next step, we can import directly the completion data. For example, the horizontal wells perforation location, also all the stages pumping schedules. So here, let me show you. So for the pumping schedule and also perforation, here we need to select load multiple stages. So we developed over the years, we developed a quick import module. A lot of other commercial software, they don't support this feature. They need to import all the perforation, all the pumping schedule one by one. So imagine you have 2 or 3 wells and maybe 100 stages of completion data. You need to do it manually, which is super time consuming. But using this interface, we are able to import them all. So the first step here, we need to select the perforation file, which is here in this folder. So the data format for the perforation is very simple. So it's just an Excel file with all the stages and all the measured depths, all the number of perforation holes, and also the hole diameter. So you can put all the stages information here. For demo purpose, this is only 5 stages, but if you have more than 20, 30, we will support that. And so we go to the next step, which is inputting the pumping schedules here. Again, we can select all of the pumping schedule at once. So for example, in this folder, we have the pumping. And we have 2 wells. Let's select the first well. So inside this folder, we have all the Excels containing the information regarding the injection rate, the pumping time, the sand concentration, and also the pressure. So we can select this folder. You can see we have 5 stages pumping schedule. And then we can batch import all of these data. For example, here we can tell the interface what is the format of these files, common name. For example, they all contain the stage. And we can click extract. And it automatically finds all these 5 stages data. And then we can click load, so that automatically all these stages data can be directly imported. You don't need to do it manually one by one. And then we go to the next step, which is we need to match all the columns, the data properties for these Excels. For example, for the first column, we have the total injection time, so we can select cumulative minutes. And we have the injection rate in the second column, and pressure, and also the sand concentration. And we can also select the units for these. All right, so now we've configured all these settings, so we can just click set. So we see that all the 5 stages pumping data are set. And now if we click OK, you will see all these pumping curves loaded into the software. And for example, for the first stage, we go to the pumping schedule, you see all the realistic data already loaded in the interface. And Then we can go on to perform the fracture propagation simulation. For example, here, we can play with different control parameters. For example, key parameters controlling the fracture height growth and also the leak off. These are the key parameters that we need to play with for each unconventional play. And here I'm using this set of parameters. And for the fracture propagation simulation, we're using the ZFRAC, called the ZFRAC. And this is based on the boundary element method. And it's a pseudo 3D model. And for the realistic model, we can consider the geology model, and we can also consider the activation of natural fractures. And a single stage of simulation run is only about less than 10 seconds, so it's super fast. So for example, let's run this first stage. So we can save the model and run. All right, you will see it's already done. This first stage already finished the simulation, and if we hide the model and we go to visualize this stage fracture geometry, you can see here this is the fracture geometry that we obtained, and we also incorporate a equilibrium height model to consider the vertical variation of the minimum horizontal stress difference between each layer. So you can see here we have a quite unique fracture height model to follow the vertical propagation. And we can also, for example, use the batch run feature here to select multiple stage to run them simultaneously. So here we already run the stage 1, so we can run the stage 2 to 5, and it's super quick. Less than a minute, we can finish all these stages simulation. And we can also see what is the geometry as the simulation progresses, and it's automatically loaded into the interface. And we can also see what is the fracture geometry that we obtained. For example, for this stage, we have around 500 to 700 feet of the fracture length, and for the height, we obtain about 30 to 50 feet of the fracture height. So we can already see that while I was talking, all the 5 stages simulation are already completed. Okay, so this is a quite straightforward a workflow as we develop over the years. And this is the fracture propagation modeling part. So you can see using less than 10 minutes, everyone is able to learn this software very quickly. And then for the reservoir simulation, we also want to evaluate what is the production potential for this well, right? So we also integrated a GPU-based reservoir simulator here. And here in the RE simulation part, we can create a new case. For example, let's name this base. And we can establish this reservoir simulation model seamlessly in the same interface. And under this base case, first we need to do the EDFM pre-processing. So this step, we need to take the complex fracture geometry here and integrate it into the regular simulation. So the first step is the bridge using the EDFM. So we are able to consider this realistic fracture boundary directly into the simulation using the EDFM pre-processing. So here we can select the well 1 as we only model the first well. And this is the interface for the EDFM. So a lot of these inputs, we don't need to manually set them because we already configured the reservoir simulation part from the first step when we import the rescue model. So you can see a lot of these input fields are automatically filled. So for the reservoir here, we have the field units and all the other information, you don't need to modify them. And for the permeability, you can play with different permeability value. I'm using the default. And for the well here, since we only consider one wells here, we just need to put one here. And then the last part is the fraction. So we can directly load these fracture geometry. So we select the well one, and we see the fraction geometry already loaded here. And you can play also with the permeability, also aperture to test with different conductivity of the fractures. And here we can directly save the fractures. Okay, and also save the input and run the EDFM. So this is a demo model. So we see that the EDFM is already completed in 4 seconds. And currently we support the parallel computing feature for the EDFM preprocessor. And just recently, we also released a new version of EDFM, which uses GPU to preprocess all the fractures. So next version of the software will also consider using the GPU EDFM version. Okay, so then we can go to the next part, which is the so-called EUR sim, the unconventional reservoir simulator, which is a GPU-based. So here we can directly open this interface here. Yeah, so here we see all the reservoir simulation input inside this interface. So and again, a lot of these inputs, we have already automated all the different entries of these inputs. So a lot of them you don't need to modify already. So for the first part, we have the I/O, which is the controlling the I/O section of the reservoir simulation, how many phases you have. So for this demo project, we have 3 phases: oil, gas, water. So here we select the black oil formulation. And all the other parts, for example, the simulation start time, if you have the customized history data, you need to select the first date that the well is put online. So for this, we will just leave everything default. And then we go to the next part, which is the reservoir. A lot of these are already ready, so you don't need to do anything because we already did the EDFM preprocessing. And also for example, the reservoir porosity, we also directly loaded this file because we configured it during the first step. So we don't need to do anything for this reservoir. And for the rock fluid part here, you can set, based on your reservoir properties, you can set the different compaction table, you can set different PVT data, and you can also set different relative permeability models. We also have quick generations of all these models here. So you can play with all different properties here based on your reservoir type. And for this case, I will just use the default. And for the region, we can also set different compaction table, different relative permeability table for the matrix and also for the fractures. So here we already have the default options for different settings for matrix and fractures. And for the initialization, we can also set different properties for the initial reservoir pore pressure. We can also set different water saturation, different gas saturation, also the bubble point settings. So here I will just leave them as default, but you have the freedom to play with all of these. And the last part is importing the well history production. So this part you need to prepare the history data file here. So for example, here we have the example history data file. So this one is just for the first one. We didn't model the second one for the time being. But for this history, you just put all the production date, the well name, and also all the phases flow rate like gas, water, oil flow rates, and also the pressure data inside the single file. And if you have multiple wells, you just put the second well's data at the very end of that file. Okay, so here in the interface, we can directly import that file. So we can select this one and go to the next step. And then you need to match different columns for your history production. So for example, the first column, we have the date, so we need to match the date. All right, here. So here we need to match the date column. We need to match the well name column. If you have multiple wells, we'll have different rows. We will need to match the oil flow rate, the gas flow rate, and also the water flow. And also we have the bottom hole pressure here. And here we have matched all the data. And for the reservoir simulation, if we want to do the history matching, we generally use the oil flow rate as the well constraint to match the other response parameters. Okay, so everything here for the reservoir simulation is done. So we can go ahead and run this model. So as we can see, this is a GPU-based reservoir simulator. So you can see for this demo model, it's runs super fast. So I tested this model. It's about 30 to 40 seconds to finish all the runs. And it's a daily production, condensed daily production data up to 2 years. And if you are using the conventional like CPU-based reservoir simulator, this might take maybe 30 minutes, an hour to finish. So we have a speed up more than 10 times. Okay, so we are almost there regarding the simulation. Yeah, so all right, it's done. All right, so how we can visualize the 2D and 3D results. So we can use this interface, a separate interface to visualize the 2D results. And we can go to the folder here, demo folder here. In the RE simulation, we have this base case, have the URC folder. So here we can directly drag the simulation results here. This one. Okay, so here we can visualize all the 2D curves. For example, your bottom hole pressure curves, your oil flow rates, your water flow rates, and also the gas flow rates. And there's a lot of other parameters as well, and you can visualize whatever you want. So this is a 2D visualization tool that we have. And then for the 3D visualization, for example, the pressure field, how we can do that. So we can go back to the interface and right-click here, load. And we can go to this folder here, and we can directly load the 3D pressure fields back into the interface. So here we can select the eGrid file. And you will see here the pressure response in the reservoir as the first well is put on the production. So we can also play with for example, the drainage volume, and also if you want to visualize each layer's pressure depletion, you can do that using the filter feature we have. And for example, if we reduce this value here, you can see the pressure drainage volume caused by these five stages fractures. And you can also visualize different layers, pressure drainage. Yeah. And you can also visualize the pressure variations inside the fractures. Okay, so this is a quick demonstration of the ZFRAC-RE software. I also want to show you a case study that we did with a rail project. So here, connecting to the remote computer. So you can see here, this is a real shale gas reservoir that we did before with 3 wells inside this model. So we have complex geology model that has some deep angles for this reservoir. And if we show the fracture geometries here, and also we have the microseismic data here. So we also support the visualization of microseismic here if you have those kind of data. So if we hide this model, you can see here for all the fractures, we are able to model for around 80 completion stages for this scenario. And you can visualize the fracture growth alongside all 3 well trajectories. And we can also see here we have complex natural fractures inside this shale gas reservoir. And we are also able to model the activation of the natural fractures. And also we have finished the reservoir simulation for this case. So you can see the complex drainage volume here for these 3 wells. And on top of that, for the reservoir simulation, we also have the capability to use the AI to help us calibrate this model. So we also developed the interface for the EDFM AI, which is the automatic history matching. So inside this interface, we are able to play with different uncertainties. One of the most important one is the percentage of the effective fracture geometry compared to your wetted geometry. As we know that if the well is put onto production, some part of fracture closes, and not all fracture lengths or height are effective, are contributing to production. So we can play with different ratios of effective geometries for both length and also the height direction. In fact, let me show you here the fracture, what we call the fracture cutoff. So for example, here you can see that if we see the wireframe that's in the purple, that is the original wetted fracture geometry simulated from the propagation model. However, when we do the calibration, we found out that only part of that fracture is effective. So you can see the yellow fractures with all the black edges. Those fracture geometries are the calibrated effective geometry with production data. So actually, only a part of them stays open, and the rest of them are closed during the production. Yeah, so we also have the EDFM AI post-processing tool. So this is the EDFM AI visualization tool. So for all these 3 wells, we are able to run multiple iterations of the calibration. And finally, we were able to give you more than 1 model. So this one, I believe it's like 10 models that calibrates the production dynamics very well. So you can see all these 3 wells, we are able to obtain a solid match using the EDFM AI module. And you are also able to see what is the posterior distribution for all these uncertainties that you consider. What is the P10, P50, P90 values for all these uncertainty parameters. And finally, we are also able to do the production forecast. So if you put the well for a long time, for example, 20 years, what EUR, gas EUR will you get out of those 3 wells. So we are able to quantify all these 3 wells, gas EUR as well. Okay, so that's all the demo about the ZFRAC-RE software interface. And as you can see here, for the ZFRAC-RE, we are still relying on a local software that you need to put onto your computer. You need to gather the license for the fracture propagation model for the GPU reservoir simulation, right? So all of those processes are kind of tedious. And at the same time, what we are developing is we are also developing a cloud-based integrated reservoir simulation platform. So let me show you that part really quick as well. So as you can see here, we have a website dedicated to cloud-based GPU reservoir simulation. This is a dedicated platform that allows you to build the reservoir model very, very quickly. And you don't need to gather the different licenses for all these kind of reservoir simulation models. So here we can see a lot of different models here. So let's dive into one of them. And here we can see that we are able to set up different workflow procedures for all these parts. For example, the rescue file import. Here we are able to do it on the cloud. And for the fracture models, we are able to directly integrate the ZFRAC results inside here. And we also have the option to quickly generate the model. For example, you don't have the geomechanics data, right? You just want to see quickly get a fracture model, like either a diamond shape fracture model or rectangular shape fracture model. We are also able to quickly generate based on your input, like for half lengths, for the height. We can also do that here very quickly. And then we also have the production data import. So for example, this is a real well. And using this, oh, sorry, I guess the laptop is also hungry. Yeah. Yeah, so using this module, we are able to quickly import all these phases flow rates. And one key features here, as you didn't see in the ZFRAC-RE, we were not able to calculate the bottom pressure if you don't have it, right? So in the cloud platform, we also developed a dedicated bottom pressure calculator, so you can quickly generate the bottom pressure using the wellhead. And we also have the integrated GPU reservoir simulation here. As you can see, all the visualizations here are dynamic, meaning when you are running the simulation, these are automatically, the results are automatically popping up. So it's automatically updating all these curves. We also integrated the all the automatic history matching features here. And another feature that I want to talk about is the fracture degradation. So this is a brand new feature that we started developing last year, and we have some application, real world application in the Bakken unconventional oil. So what the fracture degradation means is that I think this is also an industry first concept. So what this means is that instead of using the cutoff as an equivalent assumption for the fracture geometry, right, the effective versus the wetted, we are actually keeping the fracture geometry untouched from the beginning. And then as the production goes on, for example, after 1 week, 2 weeks, or several months, we are able to modify the fracture geometry. using this fracture degradation. So the effective geometry is actually dynamic. It changes over time. So this is, I believe it's industry first. We are also filing a patent for this technology. And the application of this technology, the fracture degradation in the backend, is very successful. We are able to quantify the effective fracture half length and height along with time. I will also talk about that in the next few talks. And finally, we have all these post-processing tools as well, as we showed in the ZFRAC-RE software, but this is much more user-friendly if you do it on the cloud. A lot of these, you don't need to click a lot of buttons. A lot of the visualizations are automatic. Yeah. So I think that's a good place to stop. And that's overall demo regarding our syntax software that we developed over the years regarding ZFRAC-RE and also the cloud-based platform that we are currently working on. So if you guys have any questions or interested in obtaining some of these licenses to try it on yourself, you are more than welcome to contact us. Thank you so much.
We had about 7 minutes before the next talk.